Red Sea, 2:47 a.m., March 2024, USS Dwight D. Eisenhower CVN-69 is cutting through open water at 30 knots with zero external lighting. No beacon, no signal, nothing to betray her position to the Houthi anti-ship missile batteries currently active along the Yemeni coastline. Somewhere inside that blacked-out steel hull, 5,000 Americans are working, sleeping, or eating, and not one of them can leave. 275 days without touching dry land. 17,000 meals produced every single day. $400,000 to unclog a pipe. And 5,000 people with nowhere to go. The world watches the FA-18E Super Hornet thunder off the flight deck and assumes it understands what a carrier is. It does not, because the real story is not on the flight deck. It is 4 decks below it, in a kitchen running at 135 degrees Fahrenheit, staffed by people who have not seen sunlight in 3 weeks, every single day without exception. The culinary team aboard a U.S. Navy aircraft carrier produces 17,000 individual meals, not servings. Meals plated, hot, nutritionally compliant, served on a rotating schedule that never pauses. Breakfast service begins at 3 a.m. The overnight crew feeds sailors coming off the midnight watch at 2 a.m. A fourth meal rotation called mid-rats. Midnight rations exist solely for the 0000 to 0400 watch section. Your busiest McDonald's in Manhattan might serve 1,000 customers on a peak Saturday. The carrier kitchen surpasses that output before most civilians finish their morning coffee. Spread across 5 to 7 separate galleys embedded at different levels throughout the ship. This operation runs 22 hours a day, shuts for exactly 2 hours of deep cleaning, then immediately restarts. There is no closing time. There is no slow Tuesday. There is no calling in sick. The people running those galleys are not cafeteria workers. They are culinary specialists of formal U.S. Navy rating designated CS with a dedicated training pipeline at Naval Station Great Lakes, Illinois. These are credentialed military food service professionals who understand industrial food safety codes, high volume production logistics, and the specific caloric and nutritional requirements of personnel under sustained combat tempo stress. Between 93 and 114 of them rotate through 12-hour shifts inside spaces where ambient temperature near the ovens regularly exceeds 135 degrees Fahrenheit. They are on their feet in heat that would trigger an OSHA shutdown in any civilian commercial kitchen, producing food that meets Department of Defense nutritional standards every single day for deployments that stretch past 9 months. They are not support staff. They are a weapons system component. Here is where the logistics become genuinely staggering. DoD food safety regulations mandate that perishable storage must remain at or below 41 degrees Fahrenheit at all times. The galley ovens operate at 135 degrees or higher. Both environments exist inside the same steel hull, connected by narrow passageways and near vertical ladders, moving 1,600 pounds of chicken, 350 pounds of salad greens, and 160 gallons of milk daily from refrigerated holds through a moving ship without a single container. Spending too long in a warm corridor is a precision, cold chain exercise that happens invisibly every day with zero tolerance for failure. One break in that chain means a foodborne illness event across 5,000 people, hundreds of miles from the nearest hospital. Before a strike mission, pilots flying F/A-18E and F/A-18F Super Hornets are fed to a specific nutritional profile, calibrated protein low, controlled carbohydrates, precise caloric density. This is not a perk of rank. It is a physiological requirement tied directly to aircraft performance. At certain maneuver angles, carrier pilots experience sustained G-forces up to 9 times the gravitational force, pressing blood away from the brain toward the lower body. A pilot who ate poorly or skipped a meal faces elevated risk of G-induced loss of consciousness, known as G-lock. The culinary specialists who feed that pilot before wheels up are, in a measurable and direct way, part of the strike package. When the ship shifts to battle stations configuration, the entire feeding infrastructure pivots to a parallel protocol, pre-staged combat rations, accelerated service lines, skeleton galley crews on standby. Two completely different food systems, ready to swap inside of minutes. None of this is sustainable without resupply, and the resupply process itself is one of the most quietly extraordinary operations in modern naval logistics. Every 7 to 10 days, a combat logistics force vessel, typically a Lewis and Clark class dry cargo ship, pulls alongside the carrier while both ships are underway at matched speeds. Lines are rigged across the gap. Transfer rigs begin moving cargo platforms between the hulls, frozen protein, fresh produce, dairy, dry goods, in a single underway replenishment unrep. Between 400,000 and 1 million pounds of supplies cross that open water gap, sometimes in sea states with swells exceeding 10 feet, sometimes at night under full emissions control. One snapped high line, one mistimed platform swing, and the feeding machine that keeps 5,000 people alive begins to fail. You just watched the most sophisticated food logistics operation on Earth run in complete darkness, in hostile waters, without a single day off. Now ask yourself this when that shift ends at 2 a.m. Where exactly do those 5,000 people go to sleep? It is called a rack. Not a bunk, not a bed, a rack. The dimensions are fixed by Navy specification, 72 inches long, 26 inches wide, 3-inch mattress, stacked 3 units high. The vertical clearance between your face and the metal frame above you is exactly 20 inches. You cannot sit up. You cannot roll onto your back without your knees contacting steel. Sailors have their own word for this sleeping space coffin rack, and once you hear the measurements, the name requires no further explanation. On the newest Ford-class carriers, berthing compartments are capped at 86 sailors. On older Nimitz-class ships, that same footprint held between 150 and 180 people. The improvement is real. The conditions are still unlike anything that exists in civilian life. Here's what the recruitment video does not tell you. The standard carrier watch rotation does not run on a 24-hour cycle. It runs on an 18-hour cycle, 6 hours on watch, 6 hours off, repeated continuously. This is called the 3-section watch bill, and it exists because the ship requires continuous manning across all critical stations. The problem is biological. Human circadian rhythm is anchored to a 24-hour light-dark cycle that evolved over millions of years. An 18-hour rotation means your sleep window shifts by 6 hours every single day, rotating forward around the clock in a pattern your brain cannot entrain to. The Naval Health Research Center has a clinical term for what this produces: chronic circadian misalignment. It is not tiredness. It is a measurable neurological condition. Research conducted by the Naval Health Research Center found that carrier sailors average 5.8 hours of sleep per night during the first month of deployment. By month 6, that number drops to 5.1 hours. For context, the American Academy of Sleep Medicine defines chronic sleep deprivation as consistently sleeping fewer than 7 hours per night. Every sailor on a 6-month deployment is, by clinical definition, chronically sleep deprived for the entire duration. The cognitive effects are documented: degraded reaction time, impaired working memory, reduced ability to detect errors. These are not acceptable losses in a shoreside job. On a warship operating F/A-18S, performing live ordnance handling, and manning nuclear reactor watch stations. These are serious operational risk factors that the Navy manages through crew training, redundant checklists, and sheer institutional discipline. The sound of an F/A-18E Super Hornet launching from the flight deck via the Electromagnetic Aircraft Launch System EALS registers at 150 to 165 decibels at the source. For reference, a standard gunshot produces approximately 140 to 160 decibels. The flight deck sits directly above the uppermost berthing compartments, even 4 decks below. The acoustic transfer through the hull is significant enough that sailors describe feeling the launch, physically a concussive pressure that moves through the rack frame and into the mattress. The USS Gerald R. Ford CVN-78 cost $13. $3 billion, and replaced the older steam-powered catapult system with the EALS precisely because of its mechanical advantages in launch energy control. What the engineers did not fully solve is structural acoustic transmission. The vibration signature of EALS transfers into the ship's frame differently than the old system and in certain berthing locations. Sailors report it as more pronounced, not less. The Navy allocates berthing by rank. Seamen pay grades, E1 through E3. The most junior enlisted personnel are assigned to the lowest berthing decks, closest to the engineering spaces, the propulsion machinery, and the auxiliary power generators. These are the hottest, loudest, and most mechanically active sections of the ship. It is not an oversight. It is a deliberate allocation of the worst conditions to the least senior people, consistent with how military hierarchy functions worldwide. The personal storage space allocated to each of these sailors consists of a single locker measuring 91 centimeters tall, 56 centimeters wide, and 25 centimeters deep. That is smaller than a standard checked airline bag. Everything a person owns for 9 months' uniforms, personal items, whatever small comfort they manage to bring from home lives in that space. USS Gerald R. Ford is the most technologically advanced warship ever constructed. It uses 2 A-1B nuclear reactors designed by Bechtel and manufactured under naval reactor supervision. Capable of producing 600 megawatts of thermal power, it carries an air wing of up to 90 aircraft. It can project combat power across a radius of 700 nautical miles, and its most junior sailors sleep 5 hours a night in 135-degree heat, with 20 inches of clearance above their faces, listening to 150 decibel shockwaves travel through the hull. The technology advanced. The biology did not. Sleeping 5 hours a night in a space smaller than a coffin, absorbing the acoustic shock of aircraft launches on an 18-hour watch cycle that your brain cannot biologically adapt to for 9 months straight. Now ask yourself what happens to the body and the mind when you push that past the breaking point. And what does the Navy do when the infrastructure itself starts to fail? Each berthing compartment on a carrier serves between 80 and 100 sailors. Attached to that compartment, 3 to 4 shower stalls, 3 to 4 toilet units. Do the math yourself. 1 shower for every 25 people, all of whom operate on rotating watch schedules, all of whom need to be at their duty station within minutes of waking up. There is no leisurely morning routine. There is no waiting until the bathroom clears out. At 5:30 a.m., when 3 separate watch sections are rotating simultaneously. That shower stall is the most contested piece of real estate on the ship. The Navy shower was not invented as a conservation philosophy. It was invented as a survival protocol. Wet down in under 30 seconds. Water off, soap. Rinse in under 60 seconds. Total water used approximately 11 liters. A standard American shower burns through 227 liters. On a ship, you do not have 227 liters worth of time. Here's the part that genuinely surprises people. The USS Gerald R. Ford CVN-78 does not carry its freshwater supply. It manufactures it. The ship's 2 A-1B nuclear reactors, developed under naval reactors and built by Bechtel, produce approximately 600 megawatts of thermal power. A portion of that energy drives the ship's propulsion. The remainder powers every electrical system aboard, including the reverse osmosis and multi-stage flash distillation units that pull raw seawater from the ocean and convert it into potable fresh water at a production rate of approximately 1,514,000 liters per day. That number is not a typo. CVN-78 produces enough fresh water daily to supply a small American town, and when smaller vessels in the carrier strike group run low, the carrier exports fresh water to them via UNREP transfer lines. The ship is, among other things, a floating municipal water utility. Freshwater production was solved, waste management was not. The Ford-class carriers use a pressurized vacuum waste collection system, PVWC, designed by Naval Sea Systems Command, NAVSA, to replace the older gravity-fed discharge systems. The concept is sound vacuum pressure pulls waste through a sealed pipe network, uses less water per flush than gravity systems, and takes up less hull space. The execution contained a critical engineering miscalculation. The primary waste collection lines on CVN-78 were specified at 3 inches in diameter. NAVSEA engineers calculated flow capacity based on theoretical usage models, average flushes per hour, distributed across the day. What those models did not adequately account for was simultaneous peak demand. Specifically, what happens to a 3-inch vacuum pipe when 5,000 people finish the mid-rat's meal rotation and use the bathroom within the same 45-minute window? The answer is a system-wide pressure collapse. When the PVWC network loses vacuum integrity, the failure does not stay local, because the system operates as a single pressurized network. One blockage point creates a cascade that can pull vacuum pressure from adjacent sections, triggering sequential failures across multiple decks. The Navy's remediation protocol for a Tier 1 blockage event is an acid flush industrial chemical agents pumped through hundreds of feet of interconnected piping to dissolve accumulated waste material and restore pressure integrity. The cost of a single acid flush treatment, $400,000. Between 2016 and 2019, during CVN-78's sea trials and initial operational period, the PVWC system failed repeatedly. The Government Accountability Office's 2019 report on Ford-class deficiencies listed the vacuum waste system as one of 7 critical unresolved technical problems, a list that also included the EALS catapult and the Advanced Weapons Elevator System. A $13.3 billion warship, grounded not by enemy action, but by a plumbing specification error. The Ford-class failures were not isolated. In 2011, aboard USS George H.W. Bush CVN-77, a Nimitz-class carrier, the vacuum waste system failed across all 493 restrooms simultaneously. The failure lasted 2 weeks. Sailors improvised with industrial sinks, floor drains, and portable collection units. Repair crews worked continuous 35-hour shifts, a figure documented in internal Navy maintenance reports, to restore basic function one section at a time. The total remediation cost for that single plumbing incident exceeded $2.4 million. No aircraft was damaged, no mission was aborted, but for 2 weeks, the crew of CVN-77 managed a sanitation crisis that no amount of combat training had prepared them for. A carrier strike group can intercept a supersonic cruise missile traveling at Mach 2.5 using the RIM-162 Evolved Sea Sparrow missile system. It can coordinate air operations across a 700 nautical mile combat radius. It can sustain flight operations through sea states that would ground most civilian aircraft. And it cannot guarantee that 5,000 people will have a functioning toilet on any given Tuesday. That is not a criticism of the engineers at NAVSEA. It is an acknowledgement of something far more fundamental: technology scales to mission requirements. Human biology does not scale at all. It simply demands every hour, every day, without negotiation, that its most basic needs be met. Food, sleep, sanitation, 3 things a carrier struggles to provide without friction, failure, or a $400,000 chemical intervention. Now consider what happens when you take away the one thing that makes all of it bearable. Sunlight. Day 90. Sailors who have completed multiple deployments refer to it with the kind of quiet consistency that suggests shared experience rather than coincidence. The 90-day wall. It is not a clinical designation. It does not appear in any Navy medical manual under that name. But Naval Postgraduate School researchers studying deployment psychology have documented the pattern somewhere between day 85 and day 95 of a continuous at-sea deployment. The psychological novelty of the mission expires. The sense of purpose that carried the first 3 months does not disappear, but it recedes. What remains is something more fundamental and considerably harder to manage: pure biological endurance. The sailors who hit that wall and push through it without support are the ones who develop the long-term psychological sequelae that follow them home. The ones who have support around them at day 90 are the ones who finish the deployment intact. The majority of the 5,000 personnel aboard a carrier work below the flight deck in spaces with no natural light whatsoever. Engineering compartments, galley spaces, weapons handling areas, IT infrastructure rooms, passageways with overhead pipes and cable runs, and ceilings low enough to force a constant slight hunch. These sailors are exposed to artificial lighting, predominantly 6,500 Kelvin cool, white fluorescent, and LED panels for 14 to 16 hours per day, every day. Sunlight registers at approximately 5,500 to 6,500 Kelvin at midday, which means the spectral similarity is close enough to prevent immediate visual fatigue, but insufficient to trigger the full photobiological cascade that regulates serotonin synthesis and melatonin suppression in the human brain. The result is a progressive desynchronization of the body's hormonal rhythm. Serotonin levels decline. Melatonin regulation becomes erratic. Sleep quality degrades further on top of the circadian disruption already caused by the 18-hour watch cycle. The Navy has recognized this. Since 2022, CVN-78 has been running pilot tests of a human-centric lighting system, tunable LED panels that shift color temperature and intensity across a simulated 24-hour light cycle in selected berthing compartments. The data is still being collected. 20 years ago, a sailor on a 6-month deployment might receive one brief phone call home per month, placed through a ship's single radio telephone circuit. Today, CVN-69 sailors can video call their families using the Commercial Broadband Satellite Program, CBSP, a SATCOM system that provides internet connectivity distributed across the entire crew. The connectivity is real. The bandwidth is finite. Divided across 5,000 users during peak evening hours, the connection degrades to the point where video calls freeze, audio cuts, and the call that was supposed to provide comfort becomes a frustrating exercise in latency and dropped frames. A 2022 study conducted by researchers at the Naval Postgraduate School produced a finding that contradicts the obvious assumption sailors with frequent family contact during deployment do not consistently report lower stress levels than those with limited contact. In a significant number of cases, regular video calls home elevated feelings of isolation rather than reducing them, because watching your child's birthday party through a pixelated, 3-second delayed satellite connection from the middle of the Red Sea is not connection. It is a reminder of distance. During CVN-69's Red Sea deployment, 275 days, the longest sustained combat tempo carrier deployment. Since World War II, the ship carried a certified facility dog, not a mascot, not a pet. A professionally trained psychological support animal operating under the supervision of the ship's mental health staff. Over the course of the deployment, this animal made documented contact with an estimated 800 or more individual crew members across multiple departments. The behavioral science behind facility dogs in high-stress institutional environments is well established. Even brief, unstructured contact with a trained support animal produces measurable short-term reductions in cortisol levels and self-reported anxiety. On a ship where sunlight is rationed and privacy does not exist, a dog moving through the passageways became one of the most effective mental health interventions available. Aboard carriers on extended deployment, sunlight becomes something closer to a reward system than an environmental given. Sailors accumulate what crews informally call canteen points, earned through duty performance, watch completion, and command discretion, which can be exchanged for authorized topside time, 30 minutes on an open deck, under actual sky, breathing air that does not smell like hydraulic fluid and recycled ventilation, 30 minutes. On a ship that can sustain combat air operations for 9 months without returning to port, the most coveted non-monetary resource is half an hour of sunlight. Step back from the $13.3 billion price tag. Step back from the A-1B reactors and the EALS catapults and the RIM-162 missile systems. Step back from the 17,000 meals and the $400,000 pipe flush and the 493 broken toilets. What you are left with is this: a 19-year-old Seaman E, 2 sleeping 5 hours a night in a space smaller than a parking spot, absorbing 150 decibel shockwaves through a metal frame, eating on a schedule dictated by a watch bill their body cannot biologically adapt to, unable to see the sky for 3 weeks at a time, watching their child's first steps on a satellite feed that freezes every 4 seconds and still showing up, still doing the job, still keeping the machine alive from the inside. If that changes how you see an aircraft carrier not as a weapons platform, But as a community of 5,000 people making a daily choice that most of us will never be asked to make, then leave a like as a genuine act of recognition. And if you want to keep going deeper into the realities that mainstream coverage never reaches, the subscribe button is there. Not because we asked, because you already know there is more worth understanding.